Alright, what's up? Been a while. I'm gonna continue off where we left last time I streamed. I just finished the short questions of the HL free paper 1 over at Revision Village. Hi Jazz. And then I'm gonna go through these last 3, which are the long ones. I have 15 marks, 14 marks, 12 marks. And I feel like this is going to take even longer because of Jazz. My music is bad. It's just relaxing video game music. Anyways, while you sort yourself out, I'm going to go through these. I feel like this will probably take up most of my stream time. So, I don't know, maybe no Baba is you. I kind of enjoyed it, but I don't know how people feel. The gang's all here. But anyways. Is it really loud? Oh, I see. I can turn it down. This is not a good song. If you can't hear me, then you turn up your volume then. Okay, how is everything now? It's almost a little too loud, it seems. Okay. Anyways, you start typing your questions and I'm gonna get this done real quick. So first, we have this curve here, and we want to show that this is the derivative. Now, of course, you do have a general mix of x's and y's, so we are going to use implicit differentiation. So, if I take the derivative of that, I'm going to end up with some dy dx's. And then this part here, we use a little bit of product rule. So we're going to have minus 3y and minus 3x dy dx. And then this is going to be equal to 0. And then essentially we gather our like terms of dy dx and move everything else to one side. And it seems like I have my first question of the day, which I'll get to after I finish this up. You understand this squishing? So I've just rearranged the terms a little bit, and then at this point we take a common factor of dy dx on the left hand side, and divide, and we're done. And here it is. I have one attempt left at some of the problems and I literally cried. Well, you could have just asked me for help earlier. Okay, where's my miscellaneous help page? Probably here. Okay, let's get this first question out of the way. What the hell is this music? You guys are right. let me first change my music. I guess lo-fi again. Okay, where is this question? Determine the limit as x goes to infinity of the square root x squared minus x. Why'd you put 1x? Okay, so determine this, right? It's in the question, it literally says 1x. I mean, I guess, sure. Okay, so the issue with this one is, of course, we have an infinite limit, and then you can't just plug it in, and even if you did, you get like some weird infinity minus an infinity, which makes no sense. So what have you tried? This is kind of an odd question, and I really hope it's not one of those, you know, obscure limit questions like the one that we did last time. Pardon? What have you tried? Like, have you gone through an example that's similar to this? Because I'm gonna check this real quick. Multiply by the conjugate. Multiplying by the conjugate might clean up some things, but this one's a little odd just because normally infinite ones generally have like a fraction of some sort. Okay, apparently we should be getting -1/2. So let's just take a look at how that works out. Because there's going to be all sorts of certain things. We don't talk about school here, plate of kimchi. I'm just going to go off the hunch that maybe we are going to multiply by the conjugate. Although that doesn't quite make sense, but we'll try it anyways. Because maybe it does make sense. I really hate limit questions. Okay, so here's the conjugate, and of course you would need to multiply it to the numerator and the denominator so that you're not technically changing your question. However, well, this seems like a promising start. So what do we got? In the numerator, we have a difference of squares. So you end up with x squared minus x plus 1 minus x squared. And then on the bottom, we have this stuff here. I think this is a minus. So then this is what we have so far. And then this is better because infinite limits are very friendly if we have fractions. Now let's simplify the top a little bit. So these x's here, x squareds, actually, they cancel out. So you're just left with negative x plus 1. Cancel, cancel. And then on the bottom, we just have the same thing. Now, what would be really useful is if we could cancel out some x's on the numerator with x's in the denominator. So that's exactly what we're going to do. In the numerator, we factor out an x. So you're left with negative 1 plus 1 over x. And this is good. We do want denominators of x because our limit is to infinity. So anytime you have a denominator of x, then this thing is just going to become 0. So this is a good sign. Now on the bottom, we want to kind of do the same thing. We want to factor out an x, and then these x's will cancel out. And what should end up being a result is the only x's you have will be in denominators, so they won't matter. So first, we need to find a way to factor out an x from here. Specifically, this part here. So what I'm going to do, this is calculus, is inside the square root, you're going to factor an x squared. And the reason why you're factoring out an x squared is because you're going to end up square rooting it. So that gets you the x you need for the top. Now, you have to be a little careful with square rooting an x squared, because now that you are, in university, you have to be a little bit careful. The square root of x squared is not just x. The square root of x squared is actually the absolute value of x. And then this is going to actually change your answer, because like you said, part B was the limit to negative infinity. Are you following? Do you understand this? Play to Kenji, stop being so annoying with my other viewers. Okay, when you square root an x squared, it's not just x, it's absolute value of x. Oh, thank you, Jenny. Because if x, for example, let's say x is negative 3, right? When you square it, you get 9. And then if you square root 9, it's positive 3. So even though you started with a negative, you squared it and then you square root it, you get the positive version. So you need to be aware of this. Plus minus is when you're algebraically taking the square root of something. But that's not the case here. There's no algebra. This is just in the expression. So what happens is when you do this, it's not just an x. Okay. And then this is where the limit comes in. You have to be careful about which way it's going. Because x is going towards positive infinity, then we don't actually need the absolute value brackets, because x is always going to be positive because it's going towards positive infinity. So the brackets don't do anything. So you need to write them first, and then you need to erase them. But once you're here, then we can factor out the x in the denominator. So I'm just going to copy paste this. And we factor out the x. So then this is what we have. Now these x's can cancel out, and then you can evaluate the limit. That basically means that this term goes away and these terms go away. So look at what you're left with. In the numerator, you have -1. In the denominator, you have square root 1 plus 1, which is, you know, -1 over 2, which is the answer we saw online. So hopefully this makes sense, what we're doing. Let me know. And then the other limit, when you're going towards negative infinity, that slightly changes your limit. So all of the steps up until this point are the same. Now what we need to do is observe what does the absolute value bracket do if x is going to the negative side. If x is going to the negative side, then the brackets turn it positive. So mathematically, what these brackets are doing to the negative x is they are multiplying it by a -1. Yeah, and I'll ban you if you keep doing that. So does this make sense? We just get rid of the brackets in this situation because x is positive and the absolute value brackets don't do anything. In this limit, we already know x is negative, but we need to turn it positive, so we multiply it by negative here. So when you start doing your cancellations, it's slightly different. Take the limit, these go like that. Oh, actually, let me factor out the x first. Why do you only make the bottom one negative? This is just a replacement for the absolute value. We talked about this last time. So if x is negative, then the absolute values need to turn it positive. So then you just take this x, which you know is negative, and you multiply it by a negative. So we can change that absolute value x to negative x because I know x is negative. Okay, so then when you do your common factoring in the bottom, it's slightly different. So I'm going to factor out the x. And then you're left with a negative here from the negative from the absolute value. So things are slightly different. These x's still cancel out. And then now you can plug in infinity because x's are just in the denominators. So this goes away, this one goes away, this one goes away. And you're left with a similar limit, but on top we have -1. On the bottom, wait a minute, does this lead to issues? Because then you get 0 on the bottom, right? Because then you would have -1 plus 1, which ends up being 0. So does it not exist if you go to the negative side? Let's check real quick. To negative infinity. So you can see it doesn't exist, it goes to infinity. Because after we simplified everything, it's still a division by 0. Are you still with me? Yeah, it's good for checking your answers. Bruno Luzzi, thanks. So yeah. Why is it infinity? Okay. So we know that it's going to be some sort of division by 0. And then if the bottom is 0, or if the bottom is, yeah, 0. Okay, so hold on, let me just recap. So multiply by the conjugate, simplify, you get this thing. Factor out an x from the top, factor out an x from the bottom, and then you're left with this. And then you have to decide whether or not it's positive or negative infinity, right? So why is it positive infinity? I need to think about that one. But it does say positive infinity. Yeah, I need to think about why that is. So why don't we revisit this in a bit? Because I need to think about that. Oh, praise Deagle, you're back. Can you help me with my calc homework? Question is, calculate the equation for a secant line connecting the points 9, f9, and is there more than this? For f of x, square root x. What's the other point? Praise Deagle. And that. Huh. Okay, so a secant line 1050 Miguel, thanks. So a secant line is a line that connects two coordinates together. So you have your two coordinates, you have an x value of 9 and a y value of f at 9. And then here's your other coordinate, which is 9.0601 and f at that x value here. And then of course you know what your function is. Your function is the square root of x. And then we need to find the equation of this line. So there are multiple ways you can write an equation of a line, but either way that you do write it, you need to find the slope or the gradient. And because we have two coordinates, the best thing to do is use, at least for where I'm from, we call it the point slope of equation of a line. So to do that, we do need to find the y values first. So f of 9 is the square root of 9, so this is just 3. And then for this one, you're going to need a calculator because, well, you have to square root this value. So take this and then we square root it. And then you get 3.01. So this is 3.01. Okay, so to find the slope from this point to this point, we just take the difference of y's. So 3.01 subtract 3, and then we divide it by the difference in the x's. So this 9.0601 minus this 9. So up top we have 0.01. On the bottom we have 0.0601. And then I don't know exactly what format you want this in, but we can write this as a fraction because normally we don't mix decimals and fractions together. That's just, it's one or the other. So I need to multiply this by 1,000 to get rid of all the decimals, and of course you would have to do the same to the top. So the slope of this line is 601 on the bottom, and then on the top is 100. And you might be able to reduce this, or you could actually just evaluate this and write it as a decimal. So again, I don't know what the formatting of your answer is or what your professor wants or whatever, but you have options. You either have this fraction, which maybe you can reduce, or you can evaluate the actual division. But this is kind of ugly. This is the decimal version. So let's just keep it like this. I'm not going to reduce it because I don't want to. So now that we have the slope, we can just take a point and then put it into point slope form. So we take the variable y, we subtract the y value of the point, we have the slope here, and then in brackets you have the variable x minus the x coordinate of the point. You could have also used this point, but it doesn't matter. So I'm going to choose the one that looks nicer. So here is the equation of the secant line. no worries. And then Jazz has another question. So the limit as x goes towards negative infinity. And then this is for 2e b drag t, thanks. E to the power of negative x minus x minus 3e to the x. Divide all of this by 5e to the negative x plus 6e to the x. I'm not going to mark your test live on stream. Okay, for this, they told us to divide every term by the highest power of e on the bottom. Okay. There's no x in the middle for the numerator. Oh, I see. Okay. Like this. Okay, so what we're going to do is we're going to do very similar to what we did here, where we factor out an x. It's just this time, we're factoring out an e to the x. So if you factor out an e to the x in the numerator, then what you're left with is you're left with e to the power of, well, 2e to the power of negative 2x minus 3. And then on the bottom, you have e to the x 5e to the negative x plus 6, like this. Okay, and then it's a very similar concept. Because you have this negative exponent, what that does is it takes the reciprocal of these two. So I'm going to actually literally write that out. But first, let's cancel these. And then what you have is, oh yeah, and then this is bad work, but I'm being lazy. You should technically write a limit in front of every expression. Oh, this should be minus 2. Minus 2. Should be minus 2. But anyways, yeah, you should write a limit in front of every expression you have before, until you actually evaluate it, but I'm just being lazy. Okay, so if we actually write this as a positive exponent, then we have 2 over e to the 2x minus 3. And then over here, we have 5e to the 2x plus 6. Now, are you sure they told you to divide by the highest power of e? Because this is what's going to happen. If I were to take x and then it becomes negative, this is my channel, I can be rude if I want to be. Then what happens is that this exponent becomes negative because x is negative. So the whole thing flips back over again. They didn't factor the ex out, it's in the example. Okay. So let me ask you something. In their example, is the limit positive infinity? Because if this question was positive infinity, then it works out. Because when you plug in positive infinity, then this just gets larger. So then the whole thing becomes 0. So the issue is this one's slightly different. This is a limit to negative infinity. if we were to have x become negative, then this exponent is negative. So then this whole thing flips back over. And then you no longer have a fraction. So because you're going to negative infinity, what we're actually going to do is slightly different. What you need to do is you should be factoring out a negative x. Sorry, is late? No, there's nothing late. Oh, you're trying to help out? What we need to do is we need to factor out a negative x instead. And it's similar logic. If this was, because this is negative, and then you take this to e to the negative x, then this ends up being positive. And we want to cancel these out because these end up being infinity. So if I factor out the negative x, then what I'm left with is 2 minus 3e to the power of 2x, and then 5 plus 6e to the 2x. Maybe this power 1/2, then limit infinite, sorry, is late, and then 20 over 500. Resultados de traducción, the previous problem. Miguel, I'm not entirely sure if which one you're talking about. Are you talking about this one? But anyways, so we're factoring out a negative x instead. The previous problem, the secant line, this one right here. But anyways, these cancel out, and then what you're left with is something that works out this time. When in trouble with negative limits equals 1 over 0. Oh, right. Are you talking about this one that we were trying to figure out why it's positive? Ah, okay. I'll revisit what you're saying in just a bit. Let me finish this up. So, Jazz, we factor out a negative x because this is the issue. When you have this to the negative and your x is negative, then it ends up being positive. So you have e to the positive infinity, which is no good. So we factor that out instead and cancel it out. And then this is okay because if you were to quote unquote plug it in, which is just for demonstration and not actually how you do it, you have 2e, is it a plus? Sure. And then because it's 2 times x and x is negative infinity, then essentially this is negative infinity here. And again, you wouldn't actually write this in your math, but I'm just showing you for demonstration. And you see, we keep that negative in the exponent because that's what makes our reciprocal. And then these cancel out. So this should be your limit, 2 over 5. So hopefully that makes sense why it's slightly different and why we're factoring out a negative x. Why did those cancel out? Well, e to the power infinity is, you know, basically infinity. So it's 6 divided by infinity. It's the same thing as this one here. Anyways, let me see in depth what Miguel's saying. So maybe that -1 to -1 to the power of 1/2 is plus or minus 1, and then -1 over 0 and -1 over 1, the limit is infinite. So I'm trying to figure out what you're saying, Miguel, because I think it has to do with this, but I'm not entirely sure. Dr. Drago, thanks. And let's see, b drag t, is this a question? Limit as x is approaching 0 for ax sine x bx? Yeah. Okay. I'm hoping that Miguel can clarify what he's trying to say. But this limit that you're asking, because it has trig in it, hopefully you are aware of your trig fundamental limits. So the fundamental limit is when x approaches 0, then sine of x over x is equal to 1. So we need this, or some version of this, to show up here. There's some basic limit rules that you can do. Like, you can split up this limit into ax over bx, and then plus sine x over bx. Lidante, thanks. And then this part of the limit's easy to evaluate because the x's cancel. And then essentially this, we just need to kind of make it look like this, and we're pretty close. What we can do is we just take out the b and write it as a coefficient, because coefficients don't affect your limit. So currently what we have is we have a over b plus 1 over b sine of x over x. And then we know that this thing is 1. Essential. Oh, thanks for the subscription. My 3rd subscriber. So basically this entire limit is just going to be a over b plus 1 over b. And then if you want to, you can just put these together as a plus 1 over b. Yeah, more primes. You're welcome? Is that like a second prime account? Oh, you convince your friends. Ah, I see. So this should be your limit. So hopefully that makes sense. B drag t. Stricker1, thanks. Are these all your friends, Maxine? Yeah, no worries. Hopefully that makes sense what we just did. Yeah, we got the exclusive emotes. Jazz, any more questions? Otherwise, I'm returning to this. So after a long detour of helping a couple people... Oh, never mind. We're going back to the detour. That's okay. Helping people that are currently in the stream is more important than me just doing math for people to watch afterwards. Yeah, I figured you had lots of questions. Okay, we have the limit as x goes to pi over 2 from the left side. And then we have e to the power of secant x. Okay. So let me just see what this is. Wow, I do have 20 viewers. Thanks. Secant is 1 over cosine x. And then I told my internet friends you existed. Cool. So I'm just doing a quick analysis right now because I'm not entirely sure what the strategy is going to be. I know secant is 1 over cosine, and I know that cosine pi over 2 is 0. So we have this issue of dividing by 0, and I don't even know if there's anything like simplifying we can do. So we're just gonna do some analysis. If I'm approaching cosine from the left side of pi over 2, if I'm approaching pi over 2 from the left side for cosine, it might help for you to envision the graph. So here's where pi over 2 is. The values of cosine are positive. So that means that this denominator is approaching the value of 0 from the positive side. So if this is approaching If this is approaching 0, then the entire denominator is approaching infinity. So then is this just not going to become infinity then? E to the power infinity is just even more infinity. And let's just check. So pi over 2, find the left limit of e to the power of secant x. So you see, from the left side, here, you don't get the negative or the 1 over 0 thing again. Okay. So let's see. We have pi over 2. You're coming from the left side. And basically, here's pi over 2 right here. And what you're doing is you're dividing these cosine values. So these values are getting closer and closer to 0. So in your exponent, we have 1, and it's being divided by these values of cosine that are slowly getting smaller and smaller. So as they are approaching 0, but they're still being positive, then this entire fraction is going to get larger because you're dividing by smaller and smaller values of cosine till eventually this thing just becomes infinity. So you're essentially evaluating, well, not evaluating, but you're interpreting this as e to the power of infinity, which is just infinity. Maxime, thanks for gifting a tier 1 sub. Again, if you don't understand, then just take values, right? Take 1 divided by 0.1, you get 10. Take 1 divided by something smaller, 0.0001, you get a larger number. And you know, as this keeps getting smaller, the result gets larger. Do you also have to evaluate the right side? Yeah, okay. So it's very similar. Is it in your homework? It's not in your homework, but you have to do it? Oh, the big small thing, yeah. Anyways, do you have to evaluate the right side as part of the next question? But not from the right side. Okay. So then you're good? What's the next question? Do you know what the intermediate value theorem? Yeah, of course I know what it is. Okay, what about it exactly? So while you type that out, I'm gonna try to finish this real quick. Never mind. Wow, you have these ready to go. Did you? You're just copy pasting them, right? Okay, so do you know what the intermediate value theorem is? Hello. Can't read that. I Dante. Yeah, you know what it is, right? So then, let's see. For x plus sine x equals 1. Oh, you don't know. Okay. So it has to do with a continuous function. So do you know what a continuous function is? Yeah. Okay. So the best way to probably be introduced to continuous functions is, let's say a function is continuous from A to B. That means that when you draw your function, you cannot lift up your pencil. So this is what it means to be continuous. So certain graphs, you know, maybe there's an asymptote. So you have to lift up your pen to draw the other side. So that's discontinuous. So if you have a continuous function, right? So let's say we're talking about x and y. So if your thing is continuous from A to B, and let's say you have your y value at A, which is, you know, the function at A, and your value at B, which is the function at B. So what the intermediate value theorem is that for any y value in between b, f of b, and f of a, there's going to be some x value that if you plug it into the function, it should equal that y value. Thanks, VW Runner. So that's what the intermediate value theorem is. Because if you have to be continuous, no matter how I draw it, this y value has to exist on the graph somewhere, which means that there's an x value that if you plug it in to the function, you get that y value that you were interested in. Does that make sense, Jesleen? So that's intermediate value theorem. It's like climbing a mountain, basically. If you start at 0 meters, and you start this at 7 o'clock, right? And then you climb the top of the mountain, which is like 1,000 meters tall, let's say, and you finish at 1 o'clock. So like 7 a.m. to 1 p.m. Because your hiking is continuous, you're not teleporting, then what the intermediate value theorem is just saying is that at any height between 0 and 1,000, at some point in the hike, you were at 700 meters at some time in between 7 and 1. You don't know what time, but you know that eventually at some point during that trip, you had to be at 700 meters because you hiked to 1,000 meters. There's no way to get from 0 to 1,000 without hitting 700 first. That's what the intermediate value theorem is. So I don't know if that helps you understand it better. Okay, so then your actual question. You have x plus sine of x equals 1. Now, does the intermediate value theorem show at least one solution on this interval 0 to pi over 4? Okay, so we just need to see if there's an x value here. Well, here. Let me change colors if I'm allowed to. So we know that this is continuous. X is continuous, sine of x is continuous. When you add them together, it's still continuous. And then it says that will this x plus sine of x eventually equal 1 somewhere in this interval of x's from 0 to pi over 4. So what you can do is you can check the endpoints and see what the values are. So if you have 0 plus sine 0, there's an ad. Yeah, I hope you guys are learning math, all of Maxime's friends from the internet. Yeah, this is because I'm a real Twitch streamer now, and your ad watches give me revenue. And let me tell you, I need a bit more money. Hey, Professor, can you grade Maxime paper? So I don't know if he told you, but anytime someone asks me to grade their stuff, then I wait an extra 3 days. So you just added 3 more days before I even look at his test. Okay, so Jesleen, I am going to check these intervals. So at 0, I have 0 plus plus 0, sine of 0. So then this is all 0. That's good. And then Max, you can't just time out people because they're asking me to grade your thing. Oh, and then I misread your question. So this is square brackets. Here. Okay, so we know that at 0, the value of this is going to be 0. And then we're just going to check out this one here. So pi over 4 plus sine pi over 4. So sine pi over 4 is something. Kale the Quail, thanks. What is pi over 4? I think it's 1 over root 2. So root 2 over 2. I'll explain the 1 in a bit. Like, this is like your... So in terms of the analogy that I was doing the hiking thing, right? This is the 700 meters. We don't do anything with that. 7-Up Cranberry, thanks. This is your 7 a.m. and this is like your 1 p.m. We need to find out what the heights are of your hike during these times. And then we need to see if, 1 is going to be in between these two, which it will be. Because obviously, you can just check the math yourself. Pi over 2, right? Or sorry, pi over 4 is 0.78. I don't know if you can see that because my calculator is a little small. Whatever. You know what? I'm just going to write here. So this thing is 0.78. And then if you're adding 2 root 2, well, you can just check what 2 root 2 is in a calculator as well. So root 2, 2. So we have 2, you square root it, you divide it by 2, and then you get 0.7, more or less. Now, if you were to add these together, then that's 1.48 or something. So because at 0, you have a value of 0, and at pi over 4, you have a value of 1.48, then by intermediate value theorem, there is going to exist some x value, some time, that you will be 1. You don't know when it is or where it is, but you do know that it has to be there because of intermediate value theorem. So does that make sense? Meanwhile, Praise Deagle with another question. What is the value of the limit as theta approaches 0 for sine theta over theta if theta is measured in degrees? That is 1, Praise Deagle. That's just something that you will eventually memorize. And normally this is just something that they tell you. So you know what happens when you divide something by something else and it equals 1? It means that they're the same. So what this is saying is that sine of theta and the actual theta itself, when you're close to 0, they're basically the same thing. So there's kind of a cool graph to see this. So here's sine of x, right? And then here is x itself. So you see that when you're kind of close to 0, right, as your limit goes to 0, the two graphs are basically the same, right around this area. So if you're dividing one by the other, well, because they're basically the same, you get 1. Now obviously this isn't true, for not close to 0, because you can see, like, even if I move just a little bit, they are different here. But the limit says that if you're close to 0, then they're basically the same thing. So if you're dividing them, well, then you get 1. What's the next one, Jasleen? I guess for those that are tuning in for my advertised IBSL, then you're going to be a little disappointed because it seems like I got a lot of homework help today. But you know what? I'm determined to at least get through this one. We did implicit differentiation to find the derivative. So then part B, we need to find the normal at this point 21 and 9. So the normal is perpendicular to the tangent. Here's my x and y. So to get the normal, we first need to find the tangent. But luckily, we do have the derivative. So I can just plug in x and y in here to get the tangent slope. So I'll just do that real quick before I answer more questions. So let's see, we have x is 21, y is 9. So 21 and 9. So 3 times 9 minus 2 times 21 over 2 times, this one should be x, 2 times 9 minus 3 times 21. And let's see, this is 27 minus 42 divided by 18 minus 63. So 27 minus 42 is something that I don't want to think about right now. Oh my gosh, 15? Negative 15? No, 25? Oh my gosh. I'm cheating. Oh, it was negative 15. Okay, and then we have, I think, negative 45. So this will reduce to positive 3 over 9, maybe? Well, actually, no. This is just 1 over 3. Okay, so here's your tangent slope at this coordinate. We want the normal. So our normal is the negative reciprocal. So the normal slope is negative 3. And then we know that it shares the same point. So we're going to use this in our point slope of formula. So here is the formula for the normal. All right. Now, time to go back and answer some more homework questions. Find the vertical asymptotes of this function. So what do we have? We have 2x squared plus 10x plus 8. And then we have 7x squared minus 21x minus 28. Man, these are some ugly quadratics. Okay, did your prof go over continuities with you? So there's 3 kinds of discontinuities. So you need to know kind of some background knowledge. Okay, so we have 3. They have different names depending on your prof, but you have like a jump discontinuity, but this normally only happens when you have a piecewise function. So you have like a function here, and then it switches to a different kind of function. So it's in pieces. So you literally have a jump. So we don't need to worry about that because this isn't piecewise. Otherwise, you have a removable. So this happens when, let's say you have something like this. So it's already gonna come factored, but it probably won't, like in your question right here. But let's say that this is your function, right? Now technically, you have a division by 0 when x is equal to 2. However, anytime that x is not equal to 2, then these cancel out. So essentially, everywhere but at 2, the function is basically simplified and it becomes x plus 1. So when you graph it, you put a little hole at x equals 2 because you cannot be 2. But everywhere else, it simplifies into this. So this is called removable. You basically just removed a point from a graph. And then I always forget the name. I think it's called essential or something. So essentials are when you have a division by 0, but it's not going to be canceled out. So for example, like 1 over x. There's nothing to cancel. So this is when you get a vertical asymptote. And then again, your graph can go like whatever. So essentially, if you want to find the vertical asymptotes of this, you need to factor the top, you need to factor the bottom, you need to see which factors cancel out, because those are removable discontinuities. And then any factors that aren't canceled out in the denominator, those are essential. So that's where your vertical asymptotes are going to be. Alright, 7up Cranberry says, can you help me solve the Hodge conjecture? Having a bit of trouble solving it. And then while you're at it, can you help me with the P versus NP problem? I have no idea what those are, but I feel like you're asking me very famous unsolved conjectures. And I'm going to tell you right now that I probably can't do them. But let me know if you can, because I would be interested. So start by factoring these. They're not as ugly as I initially thought. You don't get it? Here. So factor it first. And you should start with common factors. Oh, is it one of those Millennium puzzles? Isn't it called a blow-up continuity? Yeah, it depends on where you go to school and what they decide to call it. There's lots of names. It means the same thing. So first, you should take out common factors because it's a much easier question than I thought it was, because there are common factors. And then these are easy to factor, I think. Okay, so here's your denominator in factored form. So there are two values of x that are going to cause a discontinuity. And we found those out by factoring them. So if x is equal to 4, then you have 4 minus 4, which is 0. So then you divide by 0. You also have another discontinuity at x is negative 1 for the same reason. Now they are different types of discontinuity because these cancel. So because this factor of x plus 1 canceled, this is a removable one. However, you cannot cancel the x minus 4. So this one is essential or blow up, but essentially this means that you have a vertical asymptote here. So you good, Jazz? Meanwhile, I continue, and maybe I can finally finish this first question. Okay, find the distance between 2 points on the curve where each tangent is perpendicular to the y-axis. You included the minus 1, but I thought it was asking for vertical asymptotes. Or was it just asking for discontinuities in general? You don't include the negative 1. That's a removable one. Yeah, of course I'm right. Okay, let's see. So we need to find 2 points. And where those points are is where the tangent is perpendicular to the y-axis. So the y-axis is vertical, and then any lines that are perpendicular to this are horizontal. And if their tangent is horizontal, then that means that the derivative is 0. So essentially, what we're going to do is we're going to solve this for 0. Okay, so one thing to note, of course, we cannot divide by 0, so this says that 2y cannot be equal to 3x. Okay, but if you're trying to find out where a rational expression is equal to 0, once you account for where you would divide by 0, then you just ignore the denominator, because this won't make things 0. What matters is the numerator, because, you know, this is essentially a fraction. The only way you get a fraction to be 0 is if you have a 0 on the top. For example, 0 out of 7. So I am solving this equation, which says that 3y is equal to 2x. And this is good, because this is not 2y equals 3x. But then the issue is this doesn't actually tell me my coordinates. But what we can do is we know the original function. So essentially we have a system. We have a system with x and y from here, and then we have this system here. You got it? Nice. So honestly, it doesn't matter how you do your substitution. Let's just solve for y. And then we substitute this into the original function here. So we have x squared plus y squared minus 3 times x times y plus 45 is equal to 0. And then, well, we can just solve for x pretty straightforwardly. We have x squared here. We have 4 over 9 x squared here. This 3 multiplies with that fraction, and then the 3's cancel out. So we have minus x squared plus 45 equals 0. These x's cancel each other out. So you're left with 4 over 9x plus 45 x squared equals 0. And then this is pretty easy to solve for x. And then I'm just checking if I copied everything down correctly. Is this even possible? But anyways, okay, let's just see if this works. I don't think it's gonna work, so I probably messed up somewhere. Because eventually I'm going to take a square root of a negative. So something went wrong in my substitution / simplification. So I will revisit this. Okay, let's see. Next question. Why is this function discontinuous at 0? And then the function is e to the x and then x squared. They give us options. Okay. So being continuous, there's a lot of implications. So first off, you need the limit as x goes towards whatever value you're interested in of the function. You need this to be actually equal to the function at the value itself. So this is what it means to be continuous. But this has a lot of implied meaning. First off, this implies that 1, this limit actually exists. And for a limit to exist, then that's a second implication. That means that the left and right need to exist and also be the same. So there's a lot of things to check to make sure that things are continuous. So for your question, right, you have a piecewise function. You're saying that the function is two things. It's e to the power of x when x is less than 0. And then you have the function is x squared if x is greater than or equal to 0. So first off, you need to find the left and right limits. So you see this function is split at 0. So if you approach 0 from the left side, you need to observe this function. because these values are on the left of 0. So this is the limit as x approaches 0 from the negative side of e to the power of x. Okay, so there's no issue with plugging it in because you're not doing anything wrong. So this is just e to the power of 0, which is 1. Okay, then you need to check the right limit. So again, if x is approaching from the right side, then the function is x squared. Now, again, we can just plug in 0 to find this limit. It's 0. So out of all of our implications to see if something is continuous, it stops right here. The left and right side are not the same, so the limit doesn't even exist. So whichever option says that is your answer. Max really needs that paper graded ASAP? Well, if he does, then you shouldn't be adding 3 more days. What is that now? 6 days? 6 more days? So do you know which of your options is the best? Hello, Goldiflux. Congratulations on winning that tournament. If you have a graph, how do you know which points are discontinuous? Like points? What do you mean? Maintain was pretty good. He was the best that we got. Like if you just draw a random graph, okay, well you know what points of discontinuity are. If you have vertical asymptotes, then you have a discontinuity there. So that's one. If you have a hole, like an open circle, then that's a discontinuity. And then if your graph all of a sudden just jumps, then you also have a discontinuity. These are the 3 discontinuities we talked about. Yeah, I think all of our big chess players left and graduated. And now it's just a lot of casuals. What if at one x value there's a point with a hole colored and... Well, like this, you mean? Like one of these is colored in and one of these is open? This just has to be true. If you have your jump discontinuity, the dot has to be at one of them, but it can't be at both of them. It could also not have a dot at all, but you can't have both of them colored in. Because if you color them both in, yeah, those are all discontinuous except for this example. This example is just not possible. This isn't a function. Because you have, at a single x value, you have 2 different y values. So this is by definition not a function, so you're not going to see it. At most, you can have just one point colored in, and one of them has to be open. But you can also have both of them be open. But you can't have both of them be open. Or, I mean, both of them be closed and filled in. Okay, I need to see where I messed up here. So let's see, tangent is perpendicular to the y-axis. The y-axis is vertical, so perpendiculars are horizontal. So the derivative needs to be 0. The derivative, hello. The derivative is 0 at the numerator here. Yes, use my full name, please. So here's my numerator, right? 3y minus 2x. So then I bring the 2 over, divide over the 3. So then I make a substitution into here. So it's x squared y squared minus 3xy plus 45. So x squared y squared minus 3xy. Oh, man, I am bad at multiplying. Okay, these x's cancel out, but I forgot about the 2 earlier, so my bad. This is a minus 2x squared. Gaming stream? I don't know if there's time. I also don't know the reception to me playing games. Because, you know, people are here for math. So I don't know if it's going to upset them if I play game. Also, one of my dedicated viewers has a lot of questions, apparently. It could be like a what? Dessert, you know? After a long day of work. Yeah, I guess. I mean, streaming in general is just chill. I mean, you guys don't understand this because, like, who does math for fun? But it's, okay, it's not the math part, but it's the streaming part. Distracts me from work. And yeah, okay, I'm kind of doing the same thing as I would be at school, but there's less to think about. I don't need to worry about marking. I don't need to worry about, like, monitoring student behavior. Like, this is like pure math education, which is the fun stuff. So this is kind of like the dessert for me. You know, none of the bad stuff, just the good stuff. Okay, so I fixed this. And then if I collect all my x's together, I think I get negative 5 over 9 x squared. So this should work out now. So this basically means that x squared is going to be 81. So x is plus or minus 2. Okay. And then we want the distance between 2 points, so we do need to find the actual points themselves. So we have 2 points, right? We have it when x is 2 and when x is negative 2. So let's find the y coordinates for each one of these. And then the easiest one to plug it into is this equation we have isolated for y. So if I plug in 2, then I get 4 over 3. And then if I plug in negative 2, then I get negative 4 over 3. And then the distance between these 2 points is just Pythagoras. So it's 2 minus negative 2 squared plus 4 over 3 minus negative 4 over 3 squared. So I'm almost done, and then I'll check out this other question. So what is this? 16 plus 64 over 9. And then, do they, man, I can't believe they want you to do this with a calculator. I mean, it's not that bad, but I just can't think about this right now. So as a fraction, this is 144 over 9. So this is the square root of 100, 208. So root 208 over 3. Are those custom emotes from a different Twitch channel you subscribe to? Okay, what do you mean by if that makes sense? Jazz. Limit as x goes to 1 from the left. And then you have 1 over x minus 1. And then 1 over the absolute value of x minus 1. Like this. Like this, right? Okay. So we got to deal with this absolute value. So that depends on the direction your limit is coming from. If you're coming from the left side, right, then you're looking at values like 0.9. So over here, right, 0.9 minus 1 gives you a negative number. So what the absolute value does is it turns in positive. So it's the same thing as before. When you have a limit from the left side, specifically for this question, these absolute value brackets, we can replace them with multiplying this by negative, which does, again, the same thing, like that. So are you okay with this? It's the same argument as before. And then we just need to do some simplifying. First off, because now there's a negative here and we're subtracting, well, you're subtracting a negative, so we can just write this as a plus. So what we get is the limit as x goes to 1 from the left side of 2 like this. Okay, and then this, there's no fancy tricks. This is as simple as it gets. So then what is what? Oh, another ad? Thank you all for the ad revenue. I gotta recoup my losses from investing in GameStop. Okay, you're back. So I added these together. And then from here, you just need to, do some analyzing. So again, from the left side, you're considering values like 0.9. If this thing is like 0.9, then what this is approaching 0 from the negative side. So if you're dividing by 0, we know it's infinity. We know that the denominator is negative, and we know that this is positive 2, so the limit is negative infinity. Sick dab. So are you okay with all of this? Yeah, okay. And then the limit changes if you're approaching from the right side. Do you have to do the right side too? No, not for this one? Okay. Still got a bunch of questions left, or have we made some decent progress? Yep, as in kind of a lot left? Okay. Well, that's fine. Although, for those that are watching, I'm a little sad. You know what you need to become a Twitch partner? You need, over 50 followers, which I have. You need to stream a certain amount of hours, which I will eventually get. I think 25. And I'm pretty close already. And you need to have streamed for at least like 2 weeks. Partner. I'm already an affiliate. But the hardest part is you need an average of 75 viewers on your stream. And I think that's impossible. RGBT, he said he showed me that there's actually another math streamer that does help. Except this dude is like a professor at like a university. So he helps all sorts of math problems, including, high level university math. And he only gets like 50 regular viewers each time he streams. And he's not like a bad personality either. So I feel like I will never become a partner. And I don't care about the money that partners get, but you get a lot of custom emote slots as a partner. Okay. Next question. Limit to infinity. What's the issue with this one? This one's pretty standard. Did you even try this one? You need more help with the negative infinity one. So do you want me to do infinity or negative infinity? You don't get the difference? Didn't your professor explain the difference? Not well. Well, what did they say? I can't even remember. Ugh. What is that snowman for? What does that mean? Okay, well, let's just check Wolfram, because I always forget the reasoning. So let's see, limit as x to negative infinity of 2x cubed minus 6x squared minus 7x divided by 2 minus 7x minus 6x to the power 3. And then you get negative 1/3. Wait, there's nothing tricky about this one. Don't these just cancel out? And then you can evaluate the limit. And then, did it say it was wrong? Because then these cancel out. And then you're just left with 2 over negative 6, which reduces to negative 1/3. It might be the same. Did you even try submitting? For this specific question, yes. The negative doesn't do anything. Like, well, okay. These fraction ones, the negative doesn't do anything because it becomes 0. The only way the negative would affect things is from these x cubes, but they cancel each other out. So yeah, the negative didn't do anything. Yeah, so you see, here's the graph, right? And then if I make a horizontal line at whatever it was, negative 1/3, right? So you see, if you go to positive infinity, the graph is approaching 1/3, the green line. And then same thing over on the other side. So here's negative 1/3, and then here's your graph. So as you head towards negative infinity, you see it gets closer and closer and closer to negative 1/3 on both sides. So I guess it wasn't that big of a deal. How about limit infinity Isn't this just 1? You should be able to do that one. Give it some thought. What happens to 10 over x as x goes to infinity? And then what happens when you take the cosine of that? You should be able to do that one on your own. Give it some thought. Give it some thought. That's impossible? Where's RGPT to yell at you for not trying on your own? First, think about what this is. Are you sure there isn't an x? Isn't it the limit as x goes to infinity? Yeah. So if x gets very large, right? Well, we've been doing that this whole time. Yeah, so it's really small. Like 0. So what's cosine of 0? Okay, let's see. We have a cubic polynomial, and then it has these 3 roots. So then we can write this cubic in factored form in terms of the roots. Now what does it say? By expanding this, we can show these 3 things. I really don't want to do that because that's very tedious. So let's just I guess I have to though. So if I expand this out, the first 2, I get this. And then now I expand it with this one. So fun. I know I asked twice already, but can you please grade Max's paper? Some friends you guys are. It's already been like 2 weeks since he wrote it. Okay, if you expand this out, I think you get something like this. This one might... Well, actually, they just told you. So you know what? You can just pretend to expand it and then just write this. But there you go. You show that B, C, and D are going to be exactly what they say. Anyways. I remember doing this question, so it's pretty fun. We know that B, this thing, is -9. And we know that C is 45. And then the roots x1, x2, and x3 form an arithmetic sequence. And then you need to show that one of the roots is 3. So this is pretty easy. First off, you have x1. And then because it's an arithmetic sequence, then x2 is x1 plus some common difference. And then x3 is x1 plus 2 common differences. And then what we're going to do is we're going to use the fact that if you add them all up and take the negative, then you have -9. Or in other words, if I add up these, I get positive 9. So if we simplify this, we get 3x1 plus 3d equals 9. And we can divide everything by 3, so you get x1 plus d is equal to 3. In other words, remember what this is. This is x2. So we've shown that one of the roots is 3. And then after that, we find the value of d. So d is x1, x2, and x3. And we need to use the second piece of information, that c is equal to 45, this thing. So copy, paste. So this is 45. And then let me check my battery level. Oh, 10%. Not looking good. I need to plug this in. Okay, this is really annoying, but my PC, it only has 4 USB 2 and 3 ports. Now, the issue here is my webcam is a USB port, my mouse is a USB port, my keyboard is a USB port, and so is my microphone. So if I want to charge my tablet, I have to unplug one of those things. So right now, my keyboard is unplugged. But I don't use it that often because I just use my pen, right? But anyways, we are going to do some substitution in here. First off, I know that x2 is 3. And I also know that x3 is x1 plus 2d. So this becomes 3x1. This becomes x1 times x1 plus 2d. And this is 3 times x1 plus 2d. And this is all equal to 45. And then at the same time, I have this original question, and I can replace this value right here with 3. So this was x2. So in other words, I have 2x1 plus 2d is equal to 6. Actually, does this even tell me anything new? Maybe not. Well, actually, okay, we're going to do a substitution. So you see my line of thinking, and again, I'm actually doing this in an inefficient way, but then this is how I would have approached it during a paper instead of doing it the better way. But you see, we have this equation, and it has 2 variables, so we can't solve. However, what we can do here is we can isolate for one of the variables, substitute it in here, and then we can solve the system. All the asymptotes, vertical and horizontal? You should be able to do those. Horizontal asymptotes are the infinite limit, and vertical asymptotes are where you divide by 0 in the denominator. Well, that's a little redundant. It's where you divide by 0. Okay, so this says that D is basically 3 minus x1. Man, this is gonna get messy. Actually, maybe it won't. So this becomes 3 minus x1. And likewise, this becomes 3 minus x1. If I can't find any value for the vertical asymptote, does it mean it doesn't exist? No. Well, it depends. Is that unfactorable? The 4x squared plus 4x plus 5? Okay, then it might not be factorable, but it might still be equal to 0. So you need to use the quadratic formula on it. Okay, what is all of this? 6 minus x1. So this one's also 6 minus x1. So what do we got? 6x1 minus x1 squared plus 18x1 minus 3x1 squared equals 45. Okay, it wasn't as ugly as I thought it would be. So rearranging this formula, I think this is it. Let's see, that's 9. Oh, oops, I forgot about this one. 9 plus 18 is 27. So that should be 27x1. And it's negative because I move it over here. And then I just swap the sides. And then this one and this one. Oh, those make 4. So this should be 4. And then I would have to factor this or use quadratic formula. Okay, so now you know for sure that that cannot be equal to 0. So that means you do not have a vertical asymptote. Okay, back to this though. We need to solve this. And this is a paper 1, so I should be able to factor this. This is a terrible question. Although it might not even be factorable, so I might need to use quadratic formula. I just find that unlikely for a paper 1. but I do not have the mental capacity to try to factor this. But they do it in a more efficient way. And they do it in a way that changes the definition of your arithmetic sequence. But it should be the same thing. So maybe I messed up my arithmetic here. Ah, I did. So this one got an x1 squared because, well, there's this x1. But this one was just a 3. So I should have just multiplied these by 3 each. And if you guys notice, I am right-clicking to delete because my keyboard is unplugged right now. Okay, so let's see. If I take this and bring it over here, then I get positive. And then I also take the 18 and bring it over. So 45 minus 18 is 27. And then this is minus 6x1. So this is way more doable. I think. Although this might not even be factorable as well. Oh wait, what am I doing? This should be a minus here, right? Ugh, late night mistakes. No, this is not a minus. You got it wrong? Do you know what happened? Okay, so let's see. First you factor out the x squared. So you get 4 plus 4 over x plus 5 over x squared. This is square rooted. And then you have the absolute value. Although that shouldn't change your answer. Now for positive infinity, these absolute value brackets don't do anything. So then you can factor this. And then on the bottom you have this. And then these cancel. So then these cancel. So it's not 1/2, you said? Interesting. Oh. Okay, hold on. I need to plug in my keyboard. Okay, let's see. So what is it, x plus 2? Over 4x squared, and then some other stuff, plus 4x plus 5. Oh, oops, and then square root. Oh no, it says 1/2. You just have an incomplete answer. Because there's 2 horizontal asymptotes. Because you also need to look at the limit when it goes to negative infinity. Which has a slightly different limit. So you see, here's your graph, right, in red. And then the blue line represents, let me see if I can change the thickness. Yeah. So you see, when x goes to infinity, it goes to the right. So you see, it approaches the 1/2. But when you go to the left, it does not approach the same horizontal asymptote. It actually approaches negative 1/2. So you see, if I move to the left, it's negative 1/2. So you have 2 horizontal asymptotes. One when you go to the right side and one when you go to the left side. So let me just do this. Yeah, horizontal asymptotes happen for infinities, both positive and negative. Sometimes they're the same, but they don't have to be, like in this example. So you see the right side has a different horizontal asymptote than the left side. Man, I don't know why I'm taking so long on this question. It shouldn't be that difficult. So I'm just checking and making sure that all of this is substituted properly. So this and this here, and here. This is 6. These two are -2, but you plus 1, so it's -1. So you have this, this, 18 minus 3x. Man, I really don't want to do it the mark scheme way, because it's really not how I would have approached this question. But I just don't see where I'm messing up. I don't know. There's something going on here. Oh well. Let me show you their way. So, because you have 3 things. Oh, nice, another one? And then instead of defining their sequence starting from the first term, and then this one is x1 plus d, and this one is x1 plus 2d, they define their sequence from the middle term. Oh, congrats. And then this one becomes x2 minus d, and this one is x3 plus d. And this is way more efficient because when you add these together and they equal 9, the d's cancel out. So immediately you get 3x2 is equal to 9. So x2 is equal to 3. But again, we did it here, and it was fine. And then hence you find the value of d. So we take this expression, and then we replace x2 with 3. And then x1 is 3 minus d, because this was x2. This is 3 minus d. Yeah, go eat some ice cream. x3 is 3 plus d. So then you end up here. So we have 9 minus 3d plus 9 minus d squared plus 9 plus 3d. and then this is equal to 45. And this is a much cleaner one than what I was trying to work with. I'm sure it's got to work out somewhere, but I probably just am messing up my arithmetic. But this one, easier to work with. So this one and this one are canceled. So you're just left with what? 27 minus d squared is equal to 45. And then we can just solve for d, although this doesn't look like it solves either. And I'm getting really impatient with this. Oh, it's complex. Maybe that's why I was getting messed up. Holy moly. Right, this is HL. My goodness, you can have complex roots. Maybe that's why this was messing me up. Okay, well, shoot. So d squared is negative 18. So d is plus or minus 3 root 2 I. Man, pulled. Oh, okay, they say root 18 I. Well, there you go. That is the difference. Hence determine the value of, oh, this d is the common difference d, which is different than this d right here. But anyways, now we need to calculate the value of the coefficient d. Oh, I guess that's why they use delta in the answer key. So this is what? x1, x2, and x3. x2 is 3. This is 3 plus root 18i. This one is 3 minus root 18i. These two are difference of squares, or they're conjugates of each other. So what we end up with if we multiply those two first is 9 plus 18. What's my favorite cheese? I don't know, brie? Brie is pretty good. So d is negative 81. Have you had boursin? Yeah, of course. Did I say blue? No, I did not say blue. I said brie. Brie. I'm not too big of a fan of blue cheese. What do you rate it? Brie? Well, it's my favorite one, so it's rated high. Alright, unless you're talking about boursin. Boursin's pretty good. It's very gentle for a goat cheese. And boursin has lots of flavors. So, it depends. Okay. I am fairly adamant that my approach is still good. I just got tripped up because I forgot that HLs can have complex stuff. Yeah, I like my goat cheese with some sort of sweetness in it. So cranberries or fruits are good. Anyways, I found out D is negative 81. I'm sure that's right. And then In another case, the three roots form a geometric sequence. Find the value of d. Oh man, and then you have to do everything all over again? Have you made a charcuterie board? No. I've had lots of charcuterie boards. Our Pro D days, when we were allowed to have them, we always have like this massive charcuterie board made by the committee. And it's really good. Okay, I am going to reapproach this question because I feel like this is still correct. It's just that there were complex roots. Yeah, we get none now. So if we do quadratic formula on this, 4 times 27 is what? 108, I want to say. Yeah, well, you can't have open food, right? So everything has to be prepackaged. Let's see, root 72 is 36 times 2, right? So this is 6 plus 6 root 2 over 2. So x1 could be 3 plus 3 root 2. In other words, oh, actually, whoops, this is negative, so then there's an I here. And then this you can rewrite as root 18. Oh my gosh, I knew it. You see, it worked. Because the difference is 18i. And then here it is. Ugh, this sucks. Oh well, we did it. That took me way too long. And I'm not even done the full question. And I really wanted to finish this. And there's a whole nother question after this one. So time for some speed running. Okay. In another case, the three roots are going to form geometric, so then we need to find the value of d again. So I'm assuming, oh yeah, it's given here, that these are still a thing. Can I copy this and then paste it again? Okay, if your roots form a geometric sequence, then you have x1 times r, and then you have that's x2, you have x1, and then you have x1 times r squared. And then when you add these together, it equals 9. And at the same time, if you basically multiply every pair together, it needs to equal 45. So what do we got? Let's multiply these two first. So then you have x1 squared times r. Then let's multiply x1 and x3. So you get x1 squared times r squared. And then these two together, x1 squared times r cubed equals 9. Or not 945, the other one. Okay, and then we need to figure this out. So let's see, what are some things that we can do? My brain is pretty fried after that last one. Time to cheat. Okay. And then, man, that's a hard question. So you know what they're telling you to do? So this is what I thought, but I didn't think that I could get anywhere with this. You can have a common factor of x1. So then you have 1 plus r squared is equal to 9. And then over here, you have some more common factors of x1 squared times r. So what are you left with? You're left with 1 plus r squared. And then this is equal to 45. And then you divide the two equations. And then all of these cancel. One of these x1 cancels. So what you're left with is you're left with the ratio is equal to 45 divided by 9, which is 5. And then now that you know that the ratio is 5, then you can solve for x1. So x1 is 1 plus 5 plus 25, which equals 9. So I'm just taking this formula right here. So x1 is 9 over 31. And then the coefficient d is negative x1 times x2. So x2 is 45 over 31 times x3, which is another thing. And do they even have a more elegant way to multiply these all together? I think this is a very cheesy question. Oh yeah. They do. Of course they do. So you have x1. You have x1 times r squared. x1 times r. Well, actually, that's in backwards order. but so here's x1, that's x2, that's x3. So all of this is x1 times r to the power 3, which is 45 over 31 to the power 3. And it's still the same thing. You have to do this huge multiplication. This is paper 1. Of course, this is paper 1 practice. Oh wait, a times r is 5. Ah man, I messed up again somewhere. This one isn't going so well. Oh, this is x1 times r is 5. So we don't know this stuff. And then this is 5. Ah, silly me. There's an x1 times an r. Okay, there you go. Probably the worst question that I've done so far. And I am fairly determined to finish this because I do not want a part 3. Okay, use De Morvis theorem to find the value of this. Okay, so the value of that is just going to be cosine 12 pi over 6 plus I sine 12 pi over 6. So essentially you're just multiplying the arguments here, the angle, by 12. So then this just becomes cosine 2 pi plus I sine 2 pi, which is just equal to 1. Okay, and then we use mathematical induction to prove this. Okay, so mathematical induction. For n being positive integers, so we have a base case, and we need to prove this. And then that's pretty self-evident. And of course you don't have to write it like this, but whatever. So anyways, definitely true for our base case. So let's assume that this is true for n equals k. So some arbitrary k. In other words, we know that this is a thing. And then now we try to prove that it's true for the k plus 1 case. Copy, paste, So the goal of mathematical induction is that once you're at this step, we want to use our assumption somewhere. In other words, I need this to show up. But that's easy enough because this is an exponent, and all of this to the power of k plus 1 is equal to all of this to the power of k multiplied by another one. And then now I can use my assumption. And I know that this is k theta plus I sine k theta and then I just need to work with this and try to show that I get a k plus 1 somewhere. So I don't exactly know where we're going, but this feels like the right direction. So if we multiply this out, what do we get? And the more I write this, the more I'm unsure. Because this is pretty darn ugly right now. And then, what, I would use some sort of trig identity? Okay, so then they're at the same step as me, and then they do compound angle formulas. So here, I knew this would happen. Okay, if I gather all of my real components, and I should have been able to see this, but I guess, you know, it's late night, and my brain is not at full capacity anymore. Okay, collect my real and imaginary components, and then these are sum of angle identities, right? So if you pull out your formula book, you will see them. Right here. So the first part is going to be this angle identity right here. So we can combine them together and make a plus b. In other words, k theta plus theta. And then the same thing, we apply the other identity, this one. And then you're basically done. Ooh boy. And then you're done. We've proved it by induction. Okay, and then now we let W be this complex number. Man, all these songs are just repeating now. Have I listened to all of them? Anyways, and then let's see. We find an expression in terms of alpha for this polynomial. And then of course, this is the conjugate. So let's just write a couple things down. Okay, so we can just essentially do substitution here. And then we're going to apply de Moivre's theorem. And then we have some cancellation. This cosine and that cosine. So what are you left with? 2I sine n times alpha. Okay. So that looks done. Then we need to show that the conjugate multiplied by the other one is equal to 1. So this thing times this thing is equal to 1. Well, that's easy enough to prove. This is a conjugate, so then you get cosine alpha squared plus sine squared alpha, and then this is a identity. This is equal to 1. So that's easy to prove. Now we need to write down and simplify this binomial expansion. So this is W minus W conjugate cubed. And at an HL level, you should be able to expand this out fairly quickly. This is W cubed plus 3 W squared W conjugate plus 3 W conjugate squared plus W conjugate cubed. And then they want to show some simplification. So let's see. Oh, this is a subtraction. And this one is a subtraction. Okay, we're gonna do some quick rearrangement. because we're probably going to use the other parts to set this up. This part, the cubes, is exactly this question right here, where I need to show that this becomes this. Whereas this part right here, let's see. I can factor out a 3w times w conjugate from here. So what am I even left with? I'm left with the w conjugate minus a w. Okay, so what do we have? This is 2I sine 3 alpha. This thing is just 1 from the earlier part. And then if you're subtracting the conjugates, what do you get? Well, let's see. Why don't I just write this down in full? Okay, cosine subtract. And you're just left with minus 2I sine alpha. And I don't know how far they want you to go. I guess I can factor out a 2I. Let's say we leave it here. Okay, and then hence we need to show that sine 3 alpha is equal to this minus that. Okay. Paste. Okay, we need to use everything we've got so far. Okay, so starting from here, I've just shown that these two are equal to each other. Now, w minus the conjugate, well, again, let's just write it out. So we have the cosine subtracting. So what you're left with is this. 2i sine alpha cubed is equal to, over here, 2i sine 3 alpha minus 3 sine alpha. Okay, so then the cube becomes negative 8i sine cubed alpha okay, and then we're almost there. So the i's cancel out, the 2 divides over here, so this becomes 4. And then we isolate for sine 3a, 3 alpha, and then you're done, I think. Oh, oops, mine are backwards. Nice. Okay, going way more smoothly than the other one. And then, is this the final question? It is. Hence, we're gonna solve this. Right here. I don't want to keep scrolling up. All right, we're going to use probably a couple of things. My instinct is we're going to use this. Right here. Well, actually here. Let's expand this out. Okay. So I know that I basically have the negative version of this identity right here that I just found out. So then this is going to become 2 sine alpha cosine alpha minus sine 3 alpha equals 0. This is a double angle identity. Oh, I'm so close to the end, I can feel it. Okay, and then we need to solve for alpha. So let's move this to the other side. I mean, you don't have to, but it just makes it more obvious what's happening. Because you have two signs that are equal to each other, then that means that their angles need to be equal. Although, wouldn't this just be alpha 0 then? Is it really that trivial of an answer? Probably not. Probably messed up somewhere. Ugh. I do not have the brain power right now to go through all of this properly. Hence, solving the equation for D, or equation 4 right here, we have this. Oh, I see. Okay. Fair. There could be multiple answers. Plus 2 pi, multiples of 2 pi. So in other words, alpha is equal to essentially multiples of 2 pi. Although that's not quite what they have. So alpha 0 or k pi minus 2 alpha. Oh. So ignore what I said. And I don't know if this shows you shifts. But essentially to solve this one, right? You can either have them equal to each other, and then that gives you your first answer, which is alpha 0. Or you need to consider that one of them is in the second quadrant, I think. This exponents and logs package was not fun? Well, maybe you should ask questions about it. You know it's not fun? Me going through this. Yeah, so it doesn't matter which one is in the second quadrant, because again, you're solving for positive stuff. So let's just say sine 2a. So the actual angle, right, is right there. So that's pi minus 2 alpha, could also equal to 3 alpha. So then you have this. So then you have pi over 5. No, it's not. It's too long, and the other one's too dumb. Well, if you've been chilling here, why haven't you asked any questions? Okay. And then this, you could have many multiples of this. Because they're dumb questions. When it asks you to graph that, well, isn't it just a graphing calculator question? So just put in your graphing calculator? But it's so long, yeah. this upcoming test is not going to go well. Well, you have a very long time to study for it. Anyways, so again, your solutions can be, there are infinite solutions, so you add 2 pi k, and then I'm just including this in the algebra. So we have 0 as our first one. We have pi over 5. This is when k is equal to 0. Then we have what? Pi. This is when k is equal to 1. When k is equal to 2, you have 4. So 6 pi over 5. But then our domain for alpha is only up till pi. So I have 3 answers, but I think the answer key had 4. There should be a 3 pi over 5 somewhere. Oh wait, this one is 3 pi over 5. And then this one's pi. Oh my gosh, that was painful. But I am done. What does 38 mean? You mean on the package I gave you? Okay, so here's the package. And we go down all the way to 38. Okay, you have 2 functions. And then you need to rewrite g so that it's in the form f of x plus natural log of something else. So we need to rewrite this as this as part of it. So one thing you can do is, the only real work that we can do is using logarithmic rules. So this we can split up into natural log x cubed plus natural log of 5. And then you can bring down the 3, and then you're done. See, this is f of x, and then this is that a value they're talking about. So then the graph of g is a transformation of the graph of f. Well, what's the transformation? We have a vertical translation up natural log 5 units. And then you're done the question. So let's see if that's even true. So we have so here's f of x, and then here's g of x. Okay, and then if I just add natural log 5, you see, now they're one in the same graph. Yeah, it's an easy question if you know what to do. But the hard part is knowing what you're trying to do. I'm not going to give you any questions that you've had for homework. They might be similar, but oh man, that was rough. This was rough. I mean, granted, it's HL, so it is difficult. And it's late night after working, so I'm not in the best math form. And then I also well, I don't want to say distracted, but you know, I have to think about a lot of things. One, I'm helping out other people. And two, streaming's tough. You have a lot of things going on at one time. So I need to think about how to do the question. I need to think about how I'm going to write it on my OneNote so that it fits in the window and everyone can see everything. I need to think about how I'm going to explain it in the best way possible. I'm reading chat and a whole bunch of, and then like lots of little considerations. So you know what? I'm gonna say I'm gonna give myself a break on this one. It was hard, but I'm sure if I focused and I was actually, you know, in the groove, it wouldn't have been too bad. Oh well. I think I'm gonna call it there. You are welcome once again, Jazz. I'm sure I'll see you again. And then, well, everyone else, I'll come back on Sunday. So have a good Friday. Have a good Saturday. And hope you guys tune in later. I'll see you later.